Hello everyone, welcome to my channel, Dream Classes with Darshan. As usual, I'm going to introduce myself. My name is Darshan, studying B Data Science in SPCE, first SEM. My library number is 23DS1568. Today's subject is Application of Chemistry for CSE stream. In that, we are going to deal with the topic Energy Storage System. Let's know what we are going to deal in today's topic. We are going to know about the energy storage system and its importance. Topics of today's class. Introduction to energy storage system. What's energy storage system? Basic components of a battery, classification of a battery, and working of its battery. Example: Na-ion battery and lithium-ion battery. And last coming to quantum dot synthesis solar cell. Coming to the storage system. A device enables the energy liberated in a chemical reaction to be converted directly into electricity, which means a chemical reaction that results in electricity. Introduction. A battery is a portable energy source with three basic components: an anode, a cathode, and an electrolyte. A battery is a device that consists of two or more galvanic cells connected in a series or in parallel, both which convert chemical energy into an electrical energy through a redox reaction. Example: lead acid battery or nickel cadmium batteries. The size of present-day batteries range from a fraction centimeter to several cubic diameters. Batteries are used in calculators, digital watches, telephones, tape recorders, and car engines, etc. The batteries is always designed with a small. Coming to the components of battery. Anode. In a battery, anode is a negatively charged electrode. It releases electrons into an external circuit by undergoing an oxidation reaction. Let me show you with an example where a metal is undergoing an oxidation reaction which gives Mn plus and n number of electrons. Coming to the cathode. In a battery, cathode is a positively charged electrode. It accepts the electrons from the external circuit by reduction method, where example Mn plus n Mn to the power n plus n number of electrons gives M, forms a metal. Coming to the electrolytic part, it provides the medium for a transfer of ions inside a cell between the anode and the cathode. A solution of acid, alkaline, or salt having an ionic conductivity is common used as electrolytes. Coming to the separator part, it is used to separate the anode and the cathode complement components in the battery to prevent an internal short circuit. As you can see here, it's a complete battery setup where the right side part is called as cathode electrolyte, right side electrolyte is called as cathode, electrode is called as cathode, and left side is called as anode, where the between this is called as separator, and the liquid medium which is present in the both in the battery is called as electrolyte. Going further, coming to the classification of batteries. Batteries are classified as primary battery, that are non-rechargeable batteries, secondary batteries, rechargeable batteries, and reserve batteries. Here we can see a primary battery. Let's know about the primary battery. Primary battery. The batteries which cannot be recharged and discarded when the battery has delivered all electrical energy in the is called as primary battery. Example: ZnMnO2 battery and lithium MnO2 battery, etc. Coming to secondary batteries. As you can see, a battery with recharge means a secondary battery means the batteries that can be rechargeable. Let's know about it. A battery which is after discharge can be recharged again by passing the electrical current through it in the positive opposite direction to that of the discharge is known as the secondary battery. Lead acid battery and nickel cadmium batteries are etc. Coming to the reserve batteries. These are the batteries which may be stored in an inactive stage and are made actively just before they are needed to use. The activation invoking by the addition of an electrolyte because one component of the electrolyte is isolated and stored in separately when the battery is required. Example: MgH2O activated battery, ZnAl2O battery, lithium lithium V2O5 battery, etc. Here you can see a battery which is a reserve battery. By adding an electrolyte, you can invoke the battery's charges and being used at any time. It is helps to store a long time until an electrolyte is passed, which invokes the battery to charge. Coming to the working of batteries, we are going to deal with the sodium ion battery here. Coming to its construction. Construction. Construction consists of anode, cathode, and electrolyte and its separator. Anode. Anode has a sodium hard carbon metal, which is represented by NaXC6, and cathode has sodium layered transition metal oxide, which is represented by Na1 minus X MO2. Electrolyte. Sodium salt NaPF6 dissolved in polyorganic solvents. Sorry, polar organic solvents. Coming to the separator part, it is porous separator, right, is used in this. Here is an example of sodium ion battery setup where you can find an anode, cathode. Let me identify later. Anode NaX6 C6, cathode Na1 minus X MO2, and the separator it and an electrolyte with an volt supply, which represents the charging of the battery. And it's working. Let's know how it works. Anode reaction. The reaction that takes place in the anode. NaXC6 that is oxidized to form Na plus X plus C6 plus 6 number of electrons. In the cathode, where the reduction takes place, Na1 minus X MO2 plus NaX plus 6 electrons give rise NaMO2. In the net cell reaction, we can see that NaXC6 plus Na1 minus X MO2 were in the form of a battery when it is in the charging or recharging mode. You can see this reaction taking place where it forms NaMO2 plus 6 carbon atoms. Moving further, we are going to deal with a lithium ion battery where it comes again under the topic of working of batteries. Second topic, lithium ion batteries. The batteries in which the lithium ions are used instead of an lithium metal, and the movement of lithium ion through an electrolyte takes place from one electron to the another electron. Such a batteries are called as lithium ion batteries, where the ions from the lithium ions from one electrode to another electrode passing is called as lithium ion batteries. And here there is no usage of metal, it is an ions. Example: lithium polymer battery and lithium carbonate oxide battery. We are going to deal with its construction of lithium cobalt oxide battery, as you can see here the name, and this is the formula. Make sure this formula is an important. Construction. Anode is used as lithium carbon metal LiXC6. Cathode, lithiumated cobalt oxide Li1 minus X COO2. And electrolyte, lithium salts dissolved in an organic solvent. Separated polyethylene or polypropylene is used. Coming to the working part, anode. In anode, oxidation takes place where LiXC6 is converted into Li plus 6 electrons and re- replete 1 electron in the charging and decharging modes. where it is a reversible reaction. COO2 plus Li plus plus E minus, where in the recharging and decharging mode gives LiCOO2 in the cathode, and overall reaction takes place while charging and decharging, where liberates some ions, or but it is irreversible in nature. Li C6 plus COO2, where in charging or decharging mode, Li give rise LiCOO2 plus 6 electrons. Quantum dots synthesized solar cells. QDSSCS. Introduction. Quantum dots are the small semiconductor nanoparticles which are dimension of nanometers. Example: cadmium cyanide, CDSCE, cadmium sulfide, CDS, lead sulfide, PBS, and zinc sulfide, ZNS, etc. In quantum dots, the electrons and holes are conformed in all the three dimensions, leading into a decreed energy level. Coming to the quadrants diagram, here you can see a major photon anode. It works. It is sorry. Quantum dots sensitized solar cells. QDSSC. Introduction. Quantum dots are the small semiconductor nanoparticles with diameter of nanometers. Ca- Example: cadmium cyanide, CDSE, cadmium sulfide, CDS, lead sulfide, PBS, zinc sulfide, ZNS, etc. In quantum dots, electrons and holes are conformed in all the three-dimensional leading to the decreed energy level. Photon anode. Let's know it about that. It is an working electrode in the cell over which a wide band gap of semiconductor light T and TiO2, ZnO, etc. is coated with a thickness of 10 mm outer layer. Photon anode is coated with an sensitized quantum dots QDS electrolyte. PLY sulfide radon couple is most commonly used electrolyte. It is an whole conductor which can be effectively taken up the holes of the nucleus. Cathode electrode. It is used as a regenerator electrode and a complete to an the circuit. This completes this slide. Let's move to the next slide. Working of QDSSC. Extraction. We are going to extract sunlight on the QDSs to form a QDS star, where the electron holes pair formation, where the QDS star undergoes a reaction which forms an QDS electron pair and hole pair. Injection process. QDS electron pair and hole pair plus TiO2 and semiconductor gives a semiconductor plus an electron pair plus QDS plus an hole pair. Energy generation, where energy generation take place in this process, where a semiconductor electron pair plus an cathode electrode give rise semiconductor plus an cathode electrode pair plus an electrical energy. Holes will be taken up by an electrolyte and it is gets reduced by and regenerated. Coming to its properties, higher the light absorption, abundant band gap, low cost and long life span. As it is in properties, it's an advantages also. And applications. Where are this QDS applicable? In portable electronics, buildings integrated with an photovoltaics off-grid power, automotors, electrical vehicles, which are available in today's day, space applications, and artificial photosynthesis. Moving further, as it comes to the last, please do like and share as I get motivated and do more videos on this. And thank you for all